Okay. Let's talk about, first of all, derivative of exponential with base other than e. Okay. So first of all, recall the derivative of e to the x is just e to the x. You guys remember that, right?
Yeah.
E to the x is its own derivative. It's also its own integral. Yeah. So what about a to the x? Or where a could be anything. Right?
Yes. Sorry.
Okay. This is just a pretty clever manipulation of algebra. A to the x.
Say a function.
A is a base. It could be any base.
Oh, it could be any base.
Right?
Oh my goodness. Everything come back to E's and LNs.
Well, actually, yeah, we can use that.
So what do you think is the caliber of knowledge I will need to know or be to possess to have a chance in this derivative pool?
Just
Is it gonna be
calculus
like
level.
crazy stuff? Like,
Just calculus level.
are there gonna be kids that are like instantaneous derivative finders?
Possible.
Calculators. Yeah, they're like human calculators.
So, are you guys okay with this definition? Doesn't e to the natural log cancel each other out? So then this a drops down as a base, but this x stays as an exponent. You guys follow?
Yeah.
E to the natural log cancel each other out, and if a is no longer inside of a natural log, and this is no longer a base, then a drops down as a base, and you just get a to the power of x again.
Is that true or like?
Okay, well, I'm just showing you that this is where this comes from. You guys okay with that?
Yeah.
Okay. If that's not doing it for you, consider this. Instead of x right there, couldn't you also put x right there?
Yeah.
And if something's in front of a natural log, doesn't it also mean that it could be an exponent?
Oh yeah.
Does that help?
Yeah, that makes sense.
Okay. And then the e and the natural log cancel off, and you're left with, obviously, a to the x. Okay.
So e to the x, the derivative of e to the x is e to the x, and the derivative of a constant to the x equals the same constant to the x?
Well, no, I'm just showing you that a to the x is equal to e to the natural log of a times x. E to the natural log of a. So far, that's all we've done.
E to the natural log.
Yeah.
Oh,
So now, what would happen if we take the derivative on both sides?
Oh. Oh, okay, I gotcha. Gotcha.
Because where we're heading is, what's the derivative of a to the x? We know that a to the x can be rewritten as e to the natural log of a times x, but the point is to find the derivative. What's that? Part of it. Part of it.
Well, the derivative of e to the natural log of ax is e to the natural log of ax, isn't it?
Okay, guys. The derivative of e to the x is the same as e to the x. Or what about e to the u?
Oh yeah.
Isn't that e to the u times u prime?
Yeah.
Well, don't we have e to some power here?
Yeah.
So then what's the derivative of this?
It would be
To that power plus times the derivative?
It's e to this power multiplied by the derivative of that power.
1 over a to the x.
So, okay, I see where you came with that.
Or is it 2 over a? Or x over a?
I'm trying to go slow enough that you guys. I don't just want to write a definition up here, and you guys have no idea where it came from. Because memorizing a definition isn't always the best. Understanding where it came from can help you reproduce the derivation if you have to. This is just e to the u, isn't it?
Mm-hmm.
And so the derivative of that is just e to the u times u prime. That's where we're heading with this. You following? So then it's e to the natural log of a x. But now we need this u prime piece right here, where this is u. Now, I know what you're all... Oh, no. Where'd it go?
Redo. Edit redo.
I know what you're all thinking. If this is u and u prime involves a natural log, it's 1 over something, right? But there's something kind of important that we're overlooking.
Oh, it can't.
Natural log of a, that's just a constant. You guys following here? X is the variable. Natural log of a is just a constant, like 2 or 3. It's just a coefficient in front of a variable. I need to make sure you guys are with me here. When you take the derivative of this expression, natural log of a, you don't have to follow that natural log differentiation rule, because the natural log of a is just a coefficient.
Oh.
Okay? Let me
Look.
let me show you something easier. What if it was just e to the 2x? What would the derivative of that be? E to the 2x multiplied by 2, right?
Right.
Well, natural log of a is just a constant. It acts like a coefficient. Okay, so it's
So it's e times the natural, e to the natural log of ax times the natural log of a.
exactly.
Whoa.
Wait, what?
Totally figured that out in my
And that's
brain.
the derivative
Natural log of
of
AX or is those two separate things?
Say again.
The 2e to the L, the natural log of AX, those two separate things? Or those,
Oh, I wrote it twice, didn't I?
yeah,
Wait,
sorry, I
wait
was
a
just
second.
confused on if
It's,
those were connected.
it's that. It's e natural log of a to the x times the natural log of a. This is e to the u right here, and this is u prime. This is the derivative. But didn't we already say that e to the natural log of ax is equal to a to the x? So then this just turns into a to the x times the natural log of a. Because e to the natural log cancel each other out, and you're just left with a to the x.
So the derivative is a to the x natural log of
The
a.
derivative is a to the x natural log of a. That's the derivative of a to the x.
So the natural log of ax, the derivative of that equals natural log of a times natural log of a.
Yep. Because if you had like 2x, what's the derivative of that?
It's 2.
Just 2. Natural log of a is just a coefficient in front of x. So if you take the derivative, you just get natural log of a.
But isn't it like natural log of a to the x? Because x is...
It's multiplied. X is a variable. Natural log of a times x is just the same as 2 times. I mean, there's no difference really. It's just a constant times a variable. And when you take the derivative of a constant times a variable, you just get that constant.
Oh. Okay, gotcha.
Following?
Yep.
So the derivative of a to the x equals this right here. That's where that all was heading.
Oh, I love when we find what people are headed.
Okay. And then you can extend that, you guys, the derivative of a to the u, where u represents an expression in terms of x. It's a to the u times u prime times the natural log of a. A to the u times u prime times the natural log of A.
Or we can create. I could either under a pine tree or
Okay,
higher.
check it out. Try some of these. Y equals 2 to the 3x. Find y prime. Go.
Alright guys, we're gonna find Y prime. Here we go. Got it.
Equals.
What? The Empire State Building. Toad's got the answer.
3x ln.
Good. What do you Fred?
Why not? I'm not sure.
I got 6x natural log. Oh, I didn't raise it. Sorry.
2 to the third.
Go 2 to the 3x.
So the derivative is equal to a to the u times u prime times the natural log of a. That's the formula.
Okay.
Where this right here you can think of as u, 2 to the u power. So it's 2 to the 3x multiplied by 3 multiplied by natural log of 2.
Where did you get the prime? That was not in the other one up there.
That's if it's a to the u power. If it's just a to the power of x,
What's the difference between A and
u is an expression in terms of x.
U? Oh. What is that?
2 to the 3x times 3 times the natural log of 2. And I'm assuming you guys remember from past algebra classes, you can't multiply the 2 and the 3 together. Right?
Of course.
Yes. But can you can't you put the 3 on top?
If you wanted to, you could move this 3 to the top and make it 2 to the third if you wanted.
Yeah, that's what I.
So
So
it
it'd
could
be
be
ln of 2 to the third.
Or it could
Be
be,
ln to 6 then?
well, you could do ln 2 to the 2 to the 3.
Oh yeah, to the 8. Would it be ln 8? Not this.
It would. I'm assuming that I haven't checked the answer in the book. I'm assuming if this were me, I would like you to put that up top there. So this is 2 to the 3x times the natural log of 2 to the third. And then you could change 2 to the third.
That's all I'm saying.
Into 8, but I don't know how the book's going to want it.
Whoa, 2 to the third is 6. Okay, you do 2 times 3.
Okay, we good on taking the derivative of bases other than e? It's a to the u times u prime times the natural log of a.
Can we do one more?
Okay, let's do one out of your.
Let's do like a really hard one.
Good trade.
I feel like this one was too easy.
Let's get tricky with it.
Here's one, part B. Y equals 3 to the 2t divided by t.
That's another 2 t's.
Find y prime. Okay, you guys have a choice. You can leave it as it is and do a quotient rule,
No.
or you can move the t up
Yay.
as a -1 exponent and do the product rule. It's your choice. Which one do you want to do?
Product rule.
Product rule?
Well, it's because I don't remember Lodi High minus High Low.
So if this is your f function and that's your g function, Then y prime is equal to f prime times g plus g prime times f.
Oh, I get you. Yeah.
That's the product rule, right?
So we would have.
So,
you need another quotient rule before you go to this competition.
Huh?
You're gonna need another quotient rule.
Of course I would.
what's f prime? 3 to the 2t times 2 times the natural log of 3. And then we multiply that by the g function. Plus g prime, which is negative t
You should make it a new version.
to the negative 2. You guys with me?
Yeah, sorry. I was trying to help.
Times 3 to the 2t. Yep.
A lot of words, letters. Ah. Negative
Which t?
t to the negative second times 2 times negative 2t.
I would leave it where it is.
3 2t.
Okay, look at this mess of an expression, you guys. We have two parts to it. There's this part and there's this part. Is there anything they have in common? They have a 3 to the 2t in common. We can there's one other thing we could factor out. We have a t to the negative 1 and a t to the negative 2. So remember, you factor out the lowest power, which is t to the negative 2. You always factor out the lowest power. So I'm going to factor out a t to the negative 2, 3 to the 2t.
Let's see what that leaves us. It leaves us a 2 natural log of 3 times t.
2 natural log of 3 times t. Oh yeah, we can move that up if you want. Natural log of 3 squared would be the natural log of 9.
Yes. I like
Times
that
t.
All plus negative t. No, did nothing. It's gone. No, minus 1.
Minus 1, there you go.
Sorry.
Minus
Just
1.
getting ahead of myself.
That's as far as I would expect you to go. That's about as tricky as it's going to get on your homework for problems like this.
Wait. Yeah, you can't pull out a t to the negative 2, can you?
You always pull out the smallest exponent.
Oh, you do?
It'd be t to the first here because negative 2 plus 1 would give you that negative 1 right there.
Aha. Gotcha.
And anything raised to the 1 power, including this itself.
Let's do, let's switch gears here. That's your answer, yeah. Let's do derivative.
Here's the one thing that always confuses me about exponents. When you go negative, doesn't it like move the decimal place instead?
If it's a base 10.
So like, what would be like 3 in the second power? Oh.
Yeah. It only moves decimals if it's a base 10 because the word decimal means 10.
Oh.
Does that make sense? So if it's like 10 to the negative 1, that moves a decimal because it's a base of 10.
That's scientific notation.
Yeah. Derivatives of logs with different bases.
I want that.
You guys already know one derivative of a log. You know this, I hope. The derivative of the natural log of u. We just talked about that.
It may or may not be on the board just now.
It's 1 over u prime. Yeah, but that's right. But it's only working with natural log. It only works with natural log. So if we had, what about log base b of x? Log base b of x. This is just another one of these clever manipulations using properties you've seen before. Does the change of base formula sound familiar from last year?
Oh, yeah.
Change of base?
Yes.
Check this out. This is something that hopefully you were shown last year. So most calculators wouldn't be able to do like log base 2 of 5. Most calculators can't do that. And so for right now we can say, well, let's just say that equals x, right?
Right.
If I want to cancel a log base 2, don't you have to use a base of 2?
Yes.
So this is the same as 5 equals 2 to the x. Would you guys agree?
Yeah.
What if I just took a natural log on both sides? Does a natural log cancel a base of 2? But doesn't that allow the x to drop down?
Yes.
So this becomes the natural log of 5 equals x times the natural log of 2.
Whoa.
And then you divide by the natural log of 2.
What is the natural log? I feel like the natural log's like the answer to everything. It's like, where is it coming from?
That's what the change of base is, you guys. The log base 2 of 5, coming back to the beginning, you guys need to follow this because this might be something you're going to have to do. The log base 2 of 5, we didn't know what it equals, so we set it equal to x. But this also equals x. So the log base 2 of 5 is equal to the natural log of 5 over the natural log of 2. That's the change of base formula. And all that is using properties of logarithms you guys have seen before. Properties of logarithms and properties of exponentials.
And that's how I have to plug it into my calculator.
If I asked you to tell me log base 2 of 5, you'd have to plug it in like this on your calculator.
Yeah.
Not
Okay.
online.
Yeah.
Divided by the actual
Like this.
Yeah, because the exponent drops down and becomes a coefficient.
Wait, can't you just go to math?
If you have an updated TI-84, it may have a log base, but most scientific calculators can't do log base 2. Anywho, this is where I'm going with this. Log base b of x. Tell me how to rewrite that, you guys, using natural logs. I just showed you. Natural log of over the natural log of b. You guys agree?
Yeah.
I don't know what natural log is.
It's just a log with a base of e.
Log base b. X.
Now, this is where we're going with this. You guys know how to take the derivative of natural log. We're not sure how to take the derivative of log base b.
So
it's just
we're gonna have
new.
a quotient rule.
Keep going. It's much more simple than that, actually.
Does this look like a quotient rule, yes or no?
Yes.
It does, doesn't it? This is the same thing that a lot of us are overlooking though in the first place. Would you have to use a quotient rule?
Yes or no? Would you have to use a quotient rule on this derivative?
No.
Guys, I need you to understand this.
Some of you are thinking right now because you're preoccupied with other things. Would you have to use a quotient rule on this?
No.
Why not?
Because the constant.
You can just take the dividing by 3 and change it to 1/3 times x squared. Right? Would you have to use a quotient rule for this? What's the difference?
Two separate functions with variables.
Variables on the top and the bottom. Right? Think really hard now about what I'm asking you. Do you have to use a quotient rule there?
B is a constant.
So no.
So no. You can rewrite this as the derivative of 1 over the natural log of b times the natural log of x. X is the variable. B is not the variable.
So this is just a constant. You guys with me now?
So the constant has nothing to do with the derivative, really. You can just leave it alone and take the derivative of natural log of x. And you know the derivative of the natural log of x.
Yeah.
It's 1 over x, right?
Somewhere. There it is.
1 over x.
Just 1 over x.
So then it's 1 over x ln b.
So the derivative is 1 over x natural log of b.
So if we were to put u in there,
Exactly. That was the next extension.
Cool.
If you're taking, so the derivative with respect to x of the log base b of u, where u represents some kind of an expression, is equal to 1 over u natural log of b multiplied by u prime.
Yes. I'm caught up to the other two.
So here's an example. Y equals the log base 10
The master of my
of the cosine of x.
It's not as hard as it seems. Well, because it's always not as hard as it seems.
Man, they're starting you off with kind of a tough one.
Don't worry. I was just saying that.
Are these some of the derivatives that they'll put in the derivative thing? In the competition?
It may be.
I think we're ready.
No, I'm not going.
What? Are we competing against BC kids?
Probably. Most likely.
Maybe.
Have you ever heard BC stories?
One
feel like
second,
it
I
should
gotta
be
figure this
great.
out before this
Yeah.
tells us how to do it.
A, B, all the way.
So first thing you probably have to do is rewrite this
ln of
as a natural log of cosine x
over
over the natural log
10
of 10.
over ln.
But then you can rewrite that as 1 over the natural log of 10 times the natural log of cosine
It's
x.
not too hard. It's just 1 over ln whatever this is. Which is,
But we're not using the again.
yeah, but we can use u. It would just
I
be,
know you can use me, but I don't think we use it.
yes we do. I know it. I know it. It's sine, it's the ln of, sine ln cosine x over ln 10.
Okay. Okay. I think both of you had the. So the derivative of natural log of something is 1 over that something, right? So it's 1 over natural log of 10 times 1 over cosine of x, but now we need to multiply that by the derivative of cosine, which is, well, the derivative of the natural log of something is equal to 1 over u prime. So then, what's the derivative of cosine? Negative sine of x. Yeah.
Oh, I was doing this.
And then sine over cosine, you guys know that? Sine over cosine
Tangent!
is tangent. So this is negative tangent of x over the natural log of 10.
Okay.
That's it.
That's exactly what I got.
Sweet.
I don't even have to use you, Fred. I don't even have to use you.
Um,
Oh, the letter. not
for
you.
some reason,
Oh, okay.
it's in here and it's going to be part of your assigned problems. They put some problems on here from stuff that they're wanting you to remember from last year. Here's what I'm talking about. This really has nothing to do with calculus. It's pre-calculus. Not trig identities. No, it's questions like this.
Augmented formation.
Solve the equation. This is what you would have done last year. If nothing else, it's just good review.
You hit the knowledge. Trying to spark all those painful memories from last year.
Does this look familiar? This really has nothing to do with calculus, but it just helps strengthen your
Skill set involving logarithms, I guess.
Inverse.
Go, do it.
3 by 3 matrices. Inverse of those.
Solve the equation.
Okay.
Okay, so we just need to split that up. Whoa.
Wasn't it 2x equals negative 4? 2 to the x equals negative 4?
close.
Oh, we're just
X to the
solving
negative
it.
4 equals x.
Oh, we're just solving it. That's easy.
Just solve for x.
we just
Negative 4 equals x.
we raise it to
X is inside of a logarithm, so cancel the logarithm with a base of 2.
x equals 1 over 16.
So x equals 1/16. They threw a bunch of these in here just to help you practice your logarithm properties.
Good. I like these.
What's that?
Now, if you were Brandon, if I were to give you the number 1,
2 to the log base 2, cancel that.
I think.
What are you confused with?
What can it be over?
Well, x was inside of a logarithm.
What x value?
The only way to cancel a logarithm is to use a base
Probably do 4 squared.
that has the same base as a
Turn
logarithm.
into 1 over 4 squared.
Not timesing it by 2. You're using a base of 2.
should be 4 to the negative 2 power. So it'd be the log of negative 2x equals 4.
What about this
Oh,
one?
and then it'd be negative 2. And then it'd be like,
3 to the x
wait a second.
equals 1 over 81.
4 to the negative.
Oh, yeah.
Log of 4x equals
Go!
4. Those are the exact same thing. Whoa! This is exactly what we were just talking about, Brandon.
What?
It's gotta be log base 3 for sure.
X is an exponent. You can't solve for x if it's an exponent. But it's only an exponent because it has a base.
So you can take the base.
Log base 3 of 1 over 81.
What cancels a base?
A logarithm.
Logarithms.
Log base 3.
Logarithms cancel bases. So x equals log base 3
I never learned it like that.
of 1
I
over
remember
81.
I always was taught like this. You go whoop, whoop, whoop. That makes sense. Whoop, yeah, whoop, whoop, whoop.
And your teacher set you up for failure.
There it is.
Okay. That's not the final answer though, you guys. 1 over 81 is 3 to the negative 4th power. Log base 3 now cancels with that base of 3 and you get negative 4. One over 81 is 3 to the negative 4th.
I think I vaguely remember this from geometry.
And if that wasn't enough, they start to throw in a bunch of crap like this.
They would never though. They would never do that.
The half-life.
Yeah.
Shut your mouth! Shut your mouth!
Don't do it.
Don't ever say Half-Life again.
The half-life of carbon-14 is
I haven't done Half-Life.
5,715 years.
5,715 years.
A sample contains 1 gram of carbon-14.
Don't they have to give you like H or something to solve these?
How much will be present in 10,000 years?
What did you say, Malak?
Now, I guess this problem depends on how you were taught this last year. There's two different ways you could have been taught this, and I'm not sure which way you guys were taught.
You probably teach it better anyways. Just teach the way you teach.
I'm just going to show you the way I always teach it. It might not be. This is exponential decay. You guys have heard it put that way? Exponential decay. One model, this isn't the only model, but one model you can use.
No.
Does this look familiar? The initial amount times e to the kt. Something going on there that's more interesting than this, Asa? This is a sub 0, that's the initial amount. This is the original amount, this is the relative growth factor, this is the amount of time. This is how it's taught in most pre-calculus textbooks.
Yes.
Alright.
So, 81 grams.
We've been given an initial amount, we've been given a time value, but we haven't been given the relative growth rate.
We need to solve for that.
What's the
So
one with H?
H, that's,
Oh, that's
pH. Yeah, that's the acidity. So here's what you're gonna have to do, you guys. First thing is to solve for K, because we don't know what K is. K is the relative growth rate. And this is how it's done in most pre-calcs book. If you start with 1 gram and allow a full half-life to transpire, then isn't 1 gram going to become half a gram?
Yes.
You guys with me? Why did 1 become 1/2?
Because it's half.
Because it's full half-life. And take a look at this equation. What's the only unknown?
Okay.
K. So now we can solve this for K. Once we have K, we plug it back in here, and then we could solve for how much is going to be left after 10,000 years. Okay? If you divide by 1, you just get 1/2. So 1/2 equals e to the K times 5715.
So, raise to the natural log.
Now you take a natural log,
Then why not the regular log?
because you want to
Because
cancel
you
the
gotta
base of
cancel
e.
Oh.
And natural log has a base of e.
Base of E.
So the natural log of 0.5 is equal to K times 5715. And then just divide by 5715.
Seems way too easy.
Yeah.
Well, this is just a relative growth factor. This is what goes in place of K.
So then you have to solve it for 10,000.
Now that we have K, we can answer the actual question. How much is going to be present after 10,000 years? So you set up your model. The amount is equal to the initial amount times E raised this power, then the natural log of 0.5 over 5715 times 10,000.
Nice. Oh, no, dude.
So that'll give you the amount after 10,000 years.
And then you plug it into your TI-89.
I'll just do it in my head right now.
Now, I would highly suggest that you break this problem up into smaller chunks rather than trying to type the whole thing in at once. Some of you might be able to do that,
I'm gonna have like
You do
26.
the
but
simplified answer.
if you're not comfortable with all the parentheses and everything else, I would suggest you break this up. So first, I'm going to do the exponent. It's the natural log of 0.5. Then you divide that by 5715. And then don't you times that by 10,000?
Then you do 1e raised to that.
And then you do 1e raised to this power
Equals. And that's how many grams you have left?
Yep.
0.3 grams?
Roughly 0.3 grams.
Which makes sense because it's almost gone through 2 whole half-lives.
Yep. So it's 0.297 grams. This is bringing you back to the good old times of pre-calc, right? Now, why when I said we're going to do half-lives, you guys whined and moaned about it?
B and N.
Yeah. What's that? What's it?
Because we didn't have the knowledge we have now.
You have more knowledge.
Our craniums are more, you know.
So, anyway, there you go. That's 5-5.
Cranium canoe. Oh, canoe.
Maybe as part of another process within a problem. Maybe.
What am I doing?
They may ask you to create a model using this method and then find a rate of change
Okay, oh, it's working.
of the model. I could see him asking something like that. To find a rate of change, you have to take the derivative of that model. That could be a potential question.
Sweet.